All right, you are welcome again. Yes, let's move further in elementary algebra. We are moving into a new section entirely. We are done with trigonometry, okay? So, it is not everything that we touched there. There are some that we actually find very difficult to turn them into video, okay? So, we will leave those ones for classroom work, okay? Now, let's see what we can do. So, those limitations cannot stop us from serving you better, okay? Now, let's see what we have. We are moving into indices, okay? We are moving into indices. And before we treat indices in full, I want you to understand some laws that are very, very essential. They are very, very important. I want you to pay attention to these laws, please, so that when we'll be solving, you will not be confused and you will not be asking questions. How is this one like this and how is this one like that? Okay? Please pay attention to these laws. I may not be referring to the law when I will be solving, okay? I'll just tell you that once you have something like this, look at what you're going to do, okay, according to the law, okay? Please listen carefully. Let's go do it together. We have just like 8 laws that are very important to us. Now, let's have the definition. We say, any function of the form y is equal to e raised to power x, it is called an exponential function. Any function of the form y is equal to e raised to power x, it is called an exponential function, where e is any positive real number called the base, and x is any real number called the index or exponent or power. We say that the x is any real number called the index or exponent or power. Okay? Good. Now we say for any positive real numbers, a, b, and any real number x and y, the following postulates hold. We're going to be making use of some numbers, and we decide to call the numbers a, b, x, and y. And we'll say that a, b is any real number, y, x, and y also real number, but a, b is positive, okay? Must be positive. Now, let's see the laws. The law number 1 is a raised to power x times a raised to power y is equal to a raised to power x plus y. Let me explain. The purpose of this video or this tutorial is for you to understand some of the terms or how to perform the operations, okay? So these laws, it has name, but I don't just want to go with name, okay? All I want is for you to get the point. All right? Now let's go. We say that when you see this expression above, let me show you what it means. When you have a number a raised to power x, and then the same number again, a raised to power another number, and then their relationship is multiplication. That is, you have multiplication sign in between them. So what you are going to do is you pick one of the base and then add their powers. Okay? For instance, if you have 5 raised to power 2, times 5 raised to power 3 is going to be 5 raised to power 5. Now, listen. In this place, the base is the same, or the bases are the same. The bases are what? The same. It doesn't hold on different bases. Okay? So, in as much the base is the same, so you just have to add their powers. Okay? Now, let's go. We are not proving the laws. Okay? I'm just giving you the laws and then examples. Now, let's go. Number 2. That is about division. When you have a raised to power x all over a raised to power y, it is the same as saying a raised to power x minus y. Now let me show you example. When you have 3 raised to power 3 all over 3 raised to power 2, it will give you 3 raised to power 3 minus 2, which will give you 3 raised to power 1, which is 1. Okay? That's good. Now you can also make use of this to solve it. When you have 3 raised to power 3 all over 3 raised to power 2, it will give you 3 raised to power 3, it will give you 3 times 3 times 3 all over 3 raised to power 2 will give you 2 times 2. Okay, so 3 will cancel 3 will cancel 3 again, remaining 3. Okay, that is it. But this is what to solve. Okay, now let's go. Number 3. When you have a raised to power x in bracket raised to power y is the same as a raised to power y in bracket raised to power x, and they are all the same as a raised to power x y. Okay, now let's see an example. We have 2 raised to power x 2 raised to power 3 in bracket raised to power 2. We say that it is the same as 2 raised to power 2 in bracket raised to power 3, which will give you 2 times 3, it will give you 6. Okay, now it will give you 2 raised to power 6. Okay, now let's go. Number 4. A raised to power 0 is equal to 1. Any number raised to power 0 is 1. Your name raised to power 0 is 1. 1 million raised to power 0 is 1. Any number at all raised to power 0 is 1. That is about this law. Number 5. A raised to power minus x is the same as 1 all over a raised to power x. Okay? Now, look at this. Where you have a raised to power minus x. Now, this minus here is the same as saying 1 all over. Okay? This minus is the same as saying 1 all over. And then, what do you have there? We have ax. Then ax. Okay? Now, this a raised to power minus x is the inverse of a number. That is, for instance, when you have when you want to find the inverse of 2, you just say 2 raised to power minus 1. Okay, it's just like inverse or something like that. Okay, now let's go. We say that a raised to power minus x is the same as 1 all over a raised to power x. All right, good. Now let's see an example. We have 2 raised to power minus 3, and we say it is the same as 1 all over 2 raised to power 3, and it is the same as 1 all over, when you perform the operation of 2 raised to power 3 to give you 2 times 2 times 2, okay? To give you 8. Now it's the same as 1 all over 8. So we can say that 2 raised to power minus 3 is the same as 1 all over 2 raised to power 3, and it's the same as 1 all over 8. Okay? Yes, that is it. Now, when you have 1 all over 8, you can also change it back. Okay? You can also say it's the same as 1 all over 2 raised to power 3 is the same as 2 raised to power minus 3. Alright? Good. Let's go. Number 6. A raised to power x all over b raised to power x is the same as saying a all over b all in bracket raised to power x. So when you open this bracket, the x will be distributed to the both terms. Okay? That is it. Now also when you say a raised to power x times b raised to power x is the same as saying a times b in bracket raised to power x, so that the x, when you open the bracket, the x will be what? Distributed to the terms in the bracket. Okay? Yeah, that is good. That is it. Now let's see an example. We have 4 raised to power 2 times 5 raised to power 2. We say it is the same as saying 4 times 5 in bracket raised to power 2. Okay? That is it. Number 7. If a raised to power x is equal to a raised to power y, then x is equal to y. A raised to power x is equal to a raised to power y, then x is equal to y. Remember, they are having the same base. Alright? That is it. Number 9, the last where we stop for today. We have a raised to power 1 all over n is the same as saying n root a. Hello? It's the same as saying what? N root a. Now let's go. When you have something like a raised to power m all over n, it's the same as saying n root a all together in bracket raised to power m. Please study this very well, because we are going to make use of these in countless of places in our solvings. Okay? Please pay attention to this. Now let me show you an example. When we have 81 raised to power 3 all over 4, what are we going to have? So we are going to have 4 root 81 all in bracket raised to power 3. Do you see it? So the number, that is the numerator, will be the power, and then the denominator will be the what? The root. Okay? Now let's go. If you want to solve this, you ask yourself a question. We have 81, and then we have 4 root 81. So this thing is just telling you what is the number that will multiply itself into 4 times, and it will give you 81. That is what this expression is talking about. 4 root 81 is saying what is a number that will multiply itself into 4 times, and it will give you what? 81. So just like when you say root 2 or square root of 4. Square root of 4 is just telling you a number that multiplies itself 2 times. It will give you what? 4. Okay? Now, likewise, when you have 4 root what? 81, it's telling you a number you can multiply that will multiply itself into 4 places, and then it will give you what? 81. So that number will give you that number will be what? 3. So when we say 3 times 3, so we give you 9. 9 times 3 to give you what? 27. 27 times 3, it will give you what? 81. So the number is 3. Now you discover that you will have power. Say it will be 3 raised to power 3. Now 3 times 3 times 3 equal to 27. Alright, these are the what? The laws in indices. Some of the laws. Please pay attention to them. Watch them all over and all over again. So now let's go deep into what? Into indices and see what we can do there. Alright? Okay.